I have a new patient. This is a defective helium leak detector. Helium leak detectors are used in vacuum systems to find very small leaks. Inside this machine there is a roughing pump, a rotary vane pump, a turbomolecular pump, which is a high vacuum pump, and a mass spectrometer, which is precisely tuned to detect helium. You would use this device by connecting it to your vacuum system through this port on the side here. The machine then pulls a vacuum on your vacuum chamber or maybe your flange, depends on where you suspect your leak. And then you can use helium and spray it around, for example, the seals or the welds. And if there is a leak, the very small helium molecule will enter into your vacuum system and be detected by the mass spectrometer inside this machine here. In an earlier video I already repaired an old defective helium leak detector where the turbomolecular pump actually sucked the oil from the roughing pump into it, but I'm not sure what is wrong with this one. I basically have no idea. So before we open it up, I would say we first clean it a little bit. And no, unlike the first helium leak detector, I can't keep this one after repairing it, if I'm actually able to repair it. It's going back to its original owner, Whistle Vacuum, but I don't have a problem with that. They helped me with a lot of projects. I mean, my vacuum chamber is made by them. And I'm just curious to see what is wrong with it and if I'm able to fix it. And while I would love to just turn it on and see what is wrong with it, maybe I'm getting an error message, I'm going to open it up first because I want to make sure that there's nothing obviously wrong which would cause more damage if I turn the unit on. These detectors have hex screws on the side here which open up and then I can just lift the back cover up. Okay. I cannot see any oil in the hose from the turbomolecular pump or the valve block to the roughing pump, so I would say it's safe to just turn it on and see what is wrong with it. You just heard the rotary vane pump starting up, and here you can see the time for the turbomolecular pump to get up to speed. Up until this point, I don't see anything wrong. But it's interesting, if you've seen the last video about my helium leak detector, you will notice that the inside looks almost identical, a little bit different, but the layout of the valve block, the turbomolecular pump, the mass spectrometer and the roughing pump is almost identical. I actually don't see anything wrong with it. Let's see if there is an error log or something. There's a service menu and of course they want a service code. Maybe it's 000. Nope. Now you can see a continuity error in my video. I actually turned this on before, but the file of my camera was corrupted. So there is a new error message. Just ignore that. It's about the ones at the bottom here. And I'm not actually sure what they mean. E056. I would have to look this up in the manual. I will just start a measurement and see what happens. That's a really pretty unit, I have to say, the curved lines here, but I think they will notice if I give them back the old helium leak detector and not this one. I mean, this seems to work fine. I don't see a problem here. Let's test the internal test leak. There is a cartridge with a calibrated leak and you can use that to test it. And I mean, it seems to check out. Not quite sure what the problem is. I just vented the port here and I would say we create an artificial leak by putting a piece of paper towel in here and then using helium to see if the machine detects it. I'm just placing a very tiny piece of paper towel between the O-ring and the flange. And I have a bottle of helium here and I will just open it up and see if the device detects it. Yeah. As you could see, it immediately detected the helium, and you can also see it on this graph here. The huge spike was me spraying helium around the flange. I will see if I find the error code in the manual. Okay, so I checked the error code 56 here, which is the one displayed. And apparently it means that the 4-line vacuum is too high, or too low, well, the pressure is too high. And there could be 3 reasons mentioned in the manual. Either the backing pump is defective, there is a leak in the vacuum system, or one of the solenoid valves is stuck. I haven't had this problem, so I'm not quite sure why. Maybe it just happens sometimes. Okay, I think I was able to recreate the fault. I just turned the unit on and off for a few times, and if I now try to evacuate the system, basically starting the helium leak detection, you can see that it's not evacuating. Oh, sorry, I touched the display. Which means the solenoid valve you can see at the side here, it's actually one of those in back there, I think. You don't hear it working when I start the measurement. It should be working. And I think that's causing the fault. I think if I leave it in this configuration for long enough, it will show a fault and tell me that there's a leak basically, because it suspects that it's just not able to evacuate it. It doesn't know the state of the solenoid valve here, so it just assumes it's open, but it's actually not. So I'm just going to wait for a few minutes and see if it shows a fault. Yeah, exactly. So that must be the problem. Let me just restart the unit. Okay, while pressing restart, I got a different error message, error 56, which was the error that was in the error history. And it's also related to valve V1 and maybe the roughing pump, which could be defective, but it's working fine, I think, because when valve 1 opens, which it did in the beginning and also today, the roughing pump works just fine. So I'm suspecting that there's a problem with valve 1. What you're hearing right now is just the turbomolecular pump spinning down. But a different thing I've noticed when I was playing around with the unit trying to recreate the fault from yesterday is that there actually seems to be some oil in the valve block here, just with my last helium leak detector I have repaired. Because, I mean, if the port here is closed off, you don't notice anything in this hose and it looks completely clear. Unlike my other helium leak detector, it was yellow, brown. But if I leave this port here open, so there is quite some airflow going through here to the roughing pump, you can actually see oil being sucked up this hose here. So what I'm going to do is remove this front panel here so that I can have access to the valve block and valve 1 and then just take a look at it. Now you can see the individual components a lot better. Right here is the turbomolecular pump I was talking about earlier. This here is the valve block where the test leak is connected and also all the solenoid valves. In the back, as I've said, the rotary vane pump. And here on the side is the mass spectrometer with the detector here at the bottom. Let me quickly explain how this helium detection actually works. As I've explained earlier, your vacuum system is connected to this port on the top here, and then the valves open so that the roughing pump in the back can apply a rough vacuum. Once the pressure is low enough, the valves to the turbomolecular pump open and it reduces the pressure even further. All the residual gas molecules in your vacuum system will travel through the turbomolecular pump to your roughing pump. But on one side of the turbomolecular pump, the mass spectrometer is connected, which means that gas molecules can also enter the mass spectrometer. Once they are in the mass spectrometer, they are being ionized, which means they are becoming charged particles. In this mass spectrometer, there is a potential difference which accelerates these ions. Through these magnets on top here, these ions are being deflected, which means that they are basically traveling in a curved line. Given that the magnetic field and the potential difference is constant, the only variable that determines how much these ions deflect is the mass of the ion itself. This unit here can actually detect different gases. It can detect helium and hydrogen, but let's just talk about helium. You can then selectively detect helium ions by placing a slit in the flight path of those ions. Heavier or lighter ions will not have the same flight path and can't enter this slit. At the bottom there's a detector which then detects those ions. That's basically the short explanation of this system. And if you're wondering, yes, these units here are absurdly expensive if you buy them new. I haven't found a price for this one here, but I wouldn't be surprised if it's upwards of $10,000. The valve I'm concerned about is the one down here, valve 1. And the fan is connected to a PCB. And I'm just being cautious by putting some paper towels at the bottom here, because I don't know how much oil is in the valve block. Yeah, that's quite a lot of oil. I was really hoping that there was only a few drops, which basically means I have to disassemble this whole thing to at least remove the whole valve block and hope that there isn't any oil that has gotten into the turbomolecular pump. I have once bought, I don't know, thousands of these small plastic bags here, and I'm putting all the screws in them, labeling them, so I can remember where everything goes. Now I should be able to remove the power supply. The turbomolecular pump connected to the mass spectrometer and also the valve block is screwed to the case from the bottom. I'm trying to not tilt this assembly in a way that the oil would flow into the turbomolecular pump here. And I will now remove the valves one by one and then remove the valve block itself. Yeah, and there's also a lot of oil inside. What you see at the bottom of the valve block right here is actually not a valve, but a pressure sensor. It should be a Pirani gauge. Okay. Yeah, they are covered in oil. That also seems to be clean, which is great. I really want to avoid having to clean the turbomolecular pump if I can. And since it was spinning up fine without excess current, I think the unit would have detected excess current. I think I don't have to clean it. Okay, let's take off the valve block. Okay. As you can see, there is a lot of oil in the valve block, but I think the turbomolecular pump is actually clean. What worries me is that there's oil dripping out of this port for the roughing pump for the turbomolecular pump. Okay, I have cleaned all the metal components with acetone and then 99.9% isopropyl alcohol. All the plastic components and O-rings and all the components containing plastic seals have only been cleaned with isopropyl alcohol to avoid the polymer being damaged by the solvent. And I would say it's now time to put it back together. I have decided not to take apart the turbomolecular pump. The only place where oil got into is this bottom port right here. And I've placed this whole unit upside down to drain all of the oil out, and there were only a few drops coming out. The top ports, which actually lead to the rotors of the turbomolecular pump, and the bottom one to the molecular drag stage, they are both clean and I can see no traces of oil. So I've decided to keep the turbomolecular pump in one part. You have to be careful. There are two different plungers for these solenoid valves. One of them has this recess at the bottom here and also uses one of those tiny green grommets at the bottom here, and the other type does not. So don't mix them up, and I would label all these valves when you take them apart. This here was the problematic valve, valve 1, and I just suspect that it wasn't working properly because it was completely submerged in oil, and maybe the resistance was too high because it feels completely fine. And I mean, sometimes it did work, you could hear it working. This right here is one of the valves, valve 2, which has these rubber grommets at the back. I'm not actually sure what they are for. I'm sure somebody had a reason to put them there. My only suspicion is that maybe because the valve is working against a vacuum, it is there to prevent the piston from slamming at the back of the solenoid valve, but just a guess. Can we please all agree to just use Torx screws? Flathead screws are so annoying. Now it is time to put the pressure sensors back. I've also cleaned them with acetone and isopropyl alcohol, and those are actually the only thing making me keep my sanity, because in both of those leak detectors there was oil in the valve block, and I was doubting if it's supposed to be that way, but the fact that these Pirani gauges here were completely filled with oil makes me absolutely certain that it's not supposed to be that way, because Pirani gauges work by measuring basically the heat conductivity, which is dependent on the air pressure, and if they are floating in oil, there's no way this would work. I also did not clean this part and the test leak because both of them were clean. Let's put it back where it came from, but first let me clean the oil I spilled earlier a little bit. So now let's screw the turbomolecular pump and valve block to the case. And last but not least, the sexy curved front panel here. And then we can test if it works. Interestingly, it seems like somebody was in here before, because there are 4 screw holes in this panel, 2 on each side, but there were only 3 screws inserted. But all 4 of these holes have threads in them. Those are self-tapping screws. So there were screws in there. Maybe one of them fell out due to vibrations, or somebody was in there and didn't put it back. Okay, let's turn it back on and see if it works. I've had the leak detector running for over an hour now and no error messages occurred. If you are wondering what I was doing for that hour, I was cleaning this beauty right here. So this is a teaser for an upcoming video. I will now check the internal test leak to make sure that the value is still in the same range as it was before. Yeah, that seems to check out. Great. And in case you're wondering, of course, the helium leak detection still works. I've also turned the unit off and on for a few times, and well, I couldn't observe the error anymore. While reassembling this unit, I thought about the fact that this one and the last helium leak detector I got from Vissel Vacuum both had the same failure, oil in the valve block and also the turbomolecular pump in case of my last detector. While it could be that those leak detectors have a significant design flaw, my suspicion is that Vissel Vacuum uses a test procedure that somehow causes oil to be sucked back from the rotary vane pump into the valve block and the turbomolecular pump. I don't know what their testing setup looks like exactly, but I know that they are using a secondary vacuum pump to evacuate the vacuum system that they are testing. And maybe they are opening a valve too quickly and suddenly applying vacuum to this test port, which then causes oil to be sucked back from the rotary vane pump in this machine. In my opinion, it shouldn't happen regardless, but Vissel Vacuum said that they will have a look at their testing procedure. I really hope you enjoyed today's video, even though it wasn't that much different to my last helium leak detector. I want to thank my Patreons from the bottom of my heart for their ongoing support, and if you want to become a Patreon, you can find a link in the video description. Other than that, thank you a lot for watching.